Hey guys, we just finished our linear algebra final around 10 p.m. So naturally, the next course of action is to demonstrate how to invert a 3x3 matrix. There are many ways to do this, but my personal favorite involves not having to find a determinant 3 times in a row, because that makes me feel unhealthy emotions towards linear algebra. So we're going to have a little starting matrix here. And we're going to find a way to find the inverse of this, which would be this. Okay, so there's a quick shortcut to do this actually, which is you append the identity matrix to the right hand side of this. So we have our original matrix over here, and then we literally just put the identity matrix here, right? It looks kind of weird, but trust me, this works. Our next steps are pretty simple actually. We just want to take our original matrix and turn it to its row reduced form. Actually, we want the row reduced echelon form in this case. So let's go ahead and do that. My first step here would be to eliminate this 2 I see by simply adding 2 of row 1 to row 2, 0, -3, 4. And then you'll notice on this side of the identity matrix, it actually does change as well. So we added 2 row 1 to row 2. So this is a 2 now. And later, after we're done, the right-hand side should be the inverse, and the left-hand side will become the reduced row echelon form, which more often than not represents the identity matrix. So we take row 3, and then we add 3 times row 2 to it, because I see a 1, and that could easily eliminate our 3. And remember what reduced row echelon form is. We need pivot columns, and in each pivot column, it should be a 1, and everything else should be a 0. Okay, so 1, 0, 0, 0, 1. This should be 0 now because -3 plus 3 times 1 is 0. And then 4 minus 3 would give us 1, which gets us closer to what we want. Now we have this nice thing over here. 2, 1, 0, and row 3 gets added 3 times of row 2, so this should be 6, and then this should be 3, and this should be 1. Now, we are out of room on this paper, so I'm going to move up here. And actually, this is our operating system's final exam, but, you know, class ended already. So, we're almost there, as you can see. These 2 columns are fully row reduced, and this one needs to be row reduced still, which is very easy because we can just row reduce upwards now that these 2 zeros can't affect these columns here. So we're gonna go ahead and do that. Let's see. I guess I'll just write the row operations real quick. So what we would do is row 1 minus 2, row 3, and we'd also do row 2 plus row 3. And row 2 plus row 3, 1, -1 plus 1, 0. Oops, game started. Okay, so I had to mute the game real quick, and I'm actually AFK right now while my friends are fighting for their lives. Anyway, where were we? Right. So we're gonna move up here, and row 1 minus 2, row 3, and row 2 plus row 3, which should be like this. This size should be 1, 0, 0, 0, 1, 0, 1, 0, 0, right? And row 3 will remain unchanged, which is 6, 3, and 1. Meanwhile, let's see, we subtracted 2 times row 3 from row 1. Let me do the math real quick. This becomes -11, I believe. And then -6, and then -2. And then finally, we added row 3 to row 2. Okay, so as I mentioned before, our goal was to go from having reduced row echelon form on this side in the form of the identity matrix to moving it on this side, basically by row reducing what we had originally on the left side. And here we are. This is now fully row reduced, and this is our inverse, this nice little 3 by 3. And then I'm actually going to plug it into a calculator real quick because I'm not very confident in my math after that exam. That's actually kind of funny. One of my friends just got a pentakill while I was explaining the question. Alright, so we plugged in our matrix values into this nice little calculator. And we're going to click calculate, which gives us -11, -6, -2, 8, 4, 1, 6, 3, and 1. -11, -6, -2, 8, 4, 1, 6, 3, and 1. So yeah, it looks like our math was right after all. And we didn't have to do any of that fancy determinant stuff. I don't know, I just like this way more. But yeah, essentially just add the identity matrix to the right hand side, fully reduce row echelon the left hand side. And in the end, the right hand 3 by 3 should be your inverse. So that would be A inverse. Yay. Alright, thank you for watching. I'm not sure why I made this video even.